Hi, good morning, doctor. My name is CHEE, and today I'll be explaining about the question interval of concavity and inflection point. So, at first, what is interval of concavity and inflection point? So, for interval of concavity means that the interval of the graph which have the concave downwards or concave upwards. And for inflection point is the point between where the graph switches from concave upwards to concave downwards right here. So at first we're going to find the inflection point. So we're going to use the equation that's given by the questions, and we're going to differentiate it twice to get the second derivative equations. So at first we're going to differentiate the equations, and we're going to get 4x cubed minus 12x squared minus 36x plus 44. And for the second derivative, which we differentiate the first derivative, we're going to get 12 bracket x plus 1 bracket x minus 3. So in order to find the inflection point, we're going to let the second derivative equals to 0 so that we can find the root of the second derivative equations, which we're going to get x equals to minus 1 and x equals to 3. So after we have gotten the x value for the inflection point, we're about to find the y value. So we sub the negative 1 into the original equations that's given by the questions to get 64, and x equals to 3 we sub into the equation, we get 64 again. So the point of inflection point is negative 1, 64, and 3, 64. Next we're going to find the concavity. So we're going to sub the value before negative 1 to find the interval of the graph to be concaving upwards or downwards. The same concept for negative 1 to 3, and of course the value up to 3. So for example, we can sub the value negative 2 or negative 3. Right here we sub negative 2 into the second derivative to find the value. If the value is positive, that means the graph is concaving upwards. So right here, when we sub the value negative 2, we get the second derivative value to be 60. So it's positive, which means the graph before negative 1 is concaving upwards. So same concept, we sub the value number 1 into the second derivative equations. We're going to get negative 36, which means that the graph between negative 1 to 3 is concaving downwards. And as we can see, the graph after number 3, after the value 3, we sub the value 4 into the equations, we get the second derivative value is 60, and get the concavity to be concaving upwards. So in conclusion, we can know that the range of the graph concaving upwards is negative infinity to negative 1 and 3 to the infinity. And for the range of graph that concave downwards is negative 1 and to 3. So I'm going to end my presentation here. I'm going to pass the sketching part to my friend Lucas. Thank you.
Alright, good morning to doctor. My name is Lucas Lim Wei Zi, and my matrix number is 156090. For now, I would like to continue to the second part of the presentation, which is about the graph sketching. So, to find the x and the y-intercept, we could substitute the x and y value equal to 0. First, we will find about the x-intercepts. So we will substitute the y value equal to 0, and then we will get x is equal to 1 minus 2 sub 3 and 1 plus 2 sub 3. So the x-intercepts are separately lies on 1 minus 2 sub 3, 0, and 1 plus 2 sub 3, 0. As for the y-intercept, we will substitute the x equal to 0, and then we will get y equal to 1, 2, 1. So the y-axis is lies on 0, 1, 2, 1. And then secondly, for the interval that is increasing and decreasing, when we're substituting the x prime x, the first derivative with 0, we'll get the test value, the interval of 1, 1 minus 2 sub 3, and 1 plus 2 sub 3. So when we're testing out the value, we could find that the interval for which the graph is decreasing will be negative infinity to 1 minus 2 sub 3, and 1 to 1 plus 2 sub 3, whereas for the interval for the graph which is increasing is 1 minus 2 sub 3 to 1 and 1 plus 2 sub 3 to infinity. Thirdly, for the local extremum point, when we're substituting the f prime x equal to 0 and looking out for the point, then we will have the two minimum point and 1 maximum point. For the two minimum points are 1 minus 2 30 and 1 plus 2 30, whereas for the maximum point it will be 144. Then for the concavity and inflection point of the curve, that based on our calculation, we get that we got two inflection point that lies on negative 164 and 364, for which the interval that the graph is concave upward is from negative infinity to negative 1 and from 3 to positive infinity, whereas for the graph that is concave downwards, that is range from negative 1 to 3. And by this we can completely sketch up our curve for the fx equal to x squared minus 2x minus 11 squared function. That's all from our group. Thank you.